All right, so I've got a couple mystery circuit boards to take a look at, and they are interconnected. Hamer V3. I'm not sure what these things do. They came out of a church. It has something to do with ringing the bells. That's all I know. So let's take a look at one of these things up on the side. Now, as you can see, the relay that's in this one is rated at 240 volts AC. You can see it right there. And the other one is much the same, 220/240 volts AC. Interestingly enough, it has bridge rectifiers right here that basically consist of 4 diodes. And I would imagine these things probably would unplug, maybe. And they do. So we can do a quick test on those diodes and see if we might have a shorted diode. There are a couple of fuses, one on each board, as you can see right there. Does not give the nomenclature for the value. And then check this out, ETA VR, 250 volts AC it looks like, made in Germany. This one's got a bunch of crud down here, not sure what that is. But anyhow, there are some numbers on the side. I doubt that you will be able to see those numbers. You might be able to see the hair on it, however. But both of them are exactly the same. And I did go ahead and find a data sheet on these time delay relay 664. And there it tells you what the nomenclature is as to what the individual part numbers actually do. There's some more data on those. So we should see 16,700 ohms of internal resistance for the coil, I do believe. Back here on the back side is a pinout. And then there's the coil, pin 1 and pin 4. And then 2 is the common, 5 is normally closed, 3 is normally open. So I would imagine, based on the numbers on the unit, this thing is meant to switch on and switch off at a certain time. And let me see if I can see anything on here. So it is a 664 P10. 50/30 is the number on the side of it there. So 664 P10, I didn't see that, but I saw 60, which is switching time, and 30, which is reset time. Let me make sure. Yeah, 664 P10. 50/30, 5 parentheses 2A, AC 220 volts. So I should get you zoomed in so you could actually see it. But hopefully you'll trust me and take my word for it. So first thing, let's go ahead and just bring out an ohm meter here, and we'll put it in the diode range, and we'll just check these diodes just for the heck of it. So just by looking at these things, I know that the positive, or the cathode, goes to that far pin. These are the AC inputs. 514, 514, and now we'll switch it back to here. And we get 514 and 516. So those 4 diodes are good. 517, 518, 516, 517, and 517. So we do not have any shorted or defective diodes. All 4 of them basically test good at this point. Let's check the fuses while we're here. So I'll put it in the beeper, or the continuity range. And then this is one of the fuses right here. And that fuse is indeed good. And am I on there? On there, yes. And then am I on here? Yes, on there. So that fuse is definitely open. It's got a little plastic, really, cover. There we go. And I don't think it's a pin fitment issue. Try to wipe it off a little bit. The fuse actually looks okay. Let me go ahead and get a zoomed in view. One moment. Okay, so there is the close-up view of the fuse. And if I put my finger behind it there, the element looks perfectly fine in here. It does not look like it is actually blown. Keeping the meter on continuity. You can hear the beep right there. And it tests good now. That's interesting. These are really cheap soldered together fuses. I mean, there's the fuse lead that comes out. And there is the fuse holder. Was it arcing? I mean, it felt like it had. No. There, look at that. Here's part of the problem right there. So let's just go ahead and give it just a bit of pre-tension on both sides. And of course, focus is all over the place. And we'll flip it back over. There is where the fuse lives. Hopefully nothing falls off here. I can't show you the meter, but maybe you can hear the beep. And we definitely do have good continuity now. Was that the whole problem? Might have been. One moment, let me zoom back out. Okay, fuse is reinstalled. Incidentally, I did look at it. It is a 3.15 amp fuse. And just taking a look at these relays, looking at the contacts inside, that one looks absolutely perfect. Basically on both sides, as you can see right there. They're both perfectly spotless and clean. However, this one tells a slightly different story. Looking at the contacts in that one, I can't see them. And I can't see the contact on that side either. I wonder, could this black dust down there have squirted out of the relay? Let's go ahead and bring up the exposure ever so slightly. I mean, just look down inside that relay. You can barely make out where the contacts might have lived at one point. So I think I need to apply power to these things. This thing, as I was going to say. So I know that over here we've got a line or live and neutral and an earth ground, and the T might be the trigger command, because the T actually is the fourth pin over. Now it's the second pin over. It's not shared. There we go. It's not shared with the other board. So we've got live, neutral, and then earth, and then the T, which is, I believe, the trigger. And then this is common. Once again, the blue wires are both common. I did ohm them, and they are tied together. I'll just show you that. There we go, 0 ohms. So looking at the T, it goes to, I've got these labeled here. So there's pin number 2, you can see a 2 right there, and it goes to pin number 4. And so if I look at the print, very overexposed, but anyhow, pin 2 is the common of the relay, and pin 4 is one side of the coil. Now, where does pin 1 end up at? There's pin 1 right there, and it ends up on one of the commons. So I don't know if the relay switches one of the commons. It's possible. I haven't really done much of a reverse engineer on this board to speak of. But I think I just want to go ahead and apply 240 volts between these two pins. And then we will trigger this pin with that said 240 volts and just see if these time delay relays are doing what they are supposed to do. So let me get a transformer. I've got an old control transformer in the garage that converts, it was meant to convert 480 or 240 down to 240 or 120, depending on how you wire the inputs and the output. So what I'm going to do is wire the output to 120, and then I'm going to reverse supply this transformer with 120 volts. I'll wire the input to 240, and we should get an isolated 240 volts into these boards. So let me go grab that. We'll get it fitted, wired up, and I shall be right back. One moment. Okay, so here's what I've got. This is a 1 kVA control transformer from Milwaukee Transformer Company in Milwaukee, Wisconsin. I wonder if they're still in business. Let me know if anybody knows. Anyhow, I am supplying 120 volts right here, and that's going in on X1 and X2. So X1 and X2, and then coming out on this side between either H4 and H3 or H2 and H1, 227 volts, 228 on that one, and 230 volts on that winding. So there's my 240 volts effectively. I could move the variac up or down to get the voltage exact, but I think 230 volts is going to be just fine. So let's get some more jumper wires on here, connect it up to that board, and see what it wants to do. One moment. Okay, so I have my control transformer set up just off screen with the yellow wire right there and the green wire running under the voltmeter going into the live and the neutral right there. So I'm just going to go ahead and put my probes on here. I'm in the low impedance mode, which adds a very small load to this thing, 3,000 ohms. And we'll just turn this up. I'm watching the current until we get up to about 230 something volts. There we go. So we're running 235 volts. I don't see any load on the meter, although the transformer is extremely inefficient. This thing is not Energy Star compliant in the least. Drawing about 60 watts just idle, sitting here doing nothing. So I've got 235 volts there. I should have the same on these leads. And yes, I do. So I have my trigger leads right here. So I need to add another jumper from here to the live, which would be the green from the transformer. So we'll go ahead and get a red lead set up here. Things might go horribly south when this happens, but my meter is fused at 4 amps. So the relay did close. I'll just leave it on there. And after maybe 30 to 60 seconds, we might hear something change. I'm not sure, because this time delay relay should be getting voltage at this point. So I'm wondering, do we have anything going from common out to here? 164 volts of DC, 160. What about if we put these two together? Yes, we have 234 volts of DC. So that's after, oh, it just clicked off. So now we've got nothing. I'll remove the trigger lead. Nothing changed. So if I just leave it, does it come back in 30 seconds? Is it automatic? I'm not sure. Is there a bimetallic strip in this thing? I would guess yes, probably so. I guess I should get a stopwatch out and we'll time this whole sequence and see what happens. Maybe there's a thermistor in there. I don't know. I am unfamiliar with this territory at this point. So I've got my Radio Shack chrometer, what do they call it? Stopwatch. That's what it is. Yes. Had this thing many, many years. Works perfect. Usually when I'm cooking steaks. Just hang it around my neck, set the timer, flip it, done. So it's not coming back. So what I'm going to do is go ahead and remove the trigger lead. I'll start the stopwatch. I'll set it right there so you can see it. And as soon as I remove the trigger lead, I will start it, and we'll wait until we hear the click again. Okay, stopwatch is stopping. Now remember, I think it said 25/50 if I'm not mistaken. So it might take up to 50 seconds for this thing to come back to life. Waiting, waiting. Well, there's 50 plus seconds. No change yet. There, it just clicked off. So I'll stop this. Do we have any voltage on the output now? And no, we do not. Okay, so I'm going to reset the stopwatch, and I will start it once I reconnect the trigger lead to it. There we go. Sorry about the glare. There we go. That should be a little bit better for you guys. So a little over 50 seconds of off delay. And I do have 230 volts on the output right now. As you can tell, we're at 23 seconds. And then it clicked off after about 26 or 27 seconds. And we'll do that one more time, as Lock Picking Lawyer says, just to make sure it was not a fluke. Okay, going once again. Now I don't think we'll get voltage on the output leads here until I reconnect the trigger wire right here. And of course we'll do the same test on this board because I believe it has independent triggers. As you can see, it has a separate trigger input right there. So my meter does not time out. 30. Sorry if this is so boring, but we're killing time, literally. 40. And 43 seconds. No output now. Reconnect it. Yes, we have output. It should go 26, 27 seconds before it triggers off once again. And then we'll do the same thing on this board. I am going to recommend to the customer that we replace that ice cube relay under my hand right there that has the distinctly dark contacts. There, it just clicked off. Okay, so I'm going to say this board is working as intended. So I will remove power there. Remove that trigger. We'll move the trigger over to this one. And we'll stop the stopwatch. Reset it. We should get a click in a second with no trigger voltage on this time delay relay right there. We'll wait till it clicks off. Stopwatch is stopped, by the way. There it did. It just clicked off. Okay, now for the other relay. Let's see. I'm going to start the stopwatch. Let me reset my meter just so it does not go to sleep. Okay, started. And we once again have 233 volts of DC coming out of this one. Now it's not rectified, so it's averaging the RMS voltage, which should be approximately the same as the input, minus a volt-ish drop across the diodes. And we'll see if this time delay relay works correctly. And it just clicked off at 36 seconds. So remove that, reset that, And as I remove the trigger lead, I'll start the stopwatch once again. Has been started. I don't even need the meter because without voltage we get no output with the trigger lead disconnected. And we'll see how long it takes to trigger off at this point. And about 40 seconds on that one. And once again, we'll do it just to make sure it was not a fluke. Okay. Trigger is activated, or voltage has been applied to it. And it clicked off at just over 20 seconds. Reset. Trigger has been removed. And about 46 and a half, 47 seconds on that one. So as far as I can tell, these boards are working as designed. So about 20 seconds on and about 50 seconds off as specified. And of course, I got my stopwatch lead wrapped up in the trigger lead. We'll just disconnect that and move it out of the way. There we go. Okay, AC power has been removed, so it is now safe to touch. Like I said, I think I might recommend to my customer that he goes ahead and replaces this relay because it's seen a lot of use. This one, not so much. I'm not sure what the difference is, what these things drive. But as far as I can tell, the only defect that I found so far is that fuse, the fuse holder, had become untensioned. So it was not applying enough tension to that side of the fuse, because as you saw when I tested it in circuit, it measured open, but the fuse actually measured good. So overall, pretty nice construction of these things, probably from the, I would guess, early 80s. Just looking at these things, I wonder if I can see any kind of a date code on these relays whatsoever. Nothing so far. Nope. And just says LY2-0 220-240 volts AC. And then all the nomenclature is on that side of the relay. And I'm not seeing a date code anywhere. What about the possibility of a date code on one of these metal oxide varistors? They are 250L40s. And the only date code I might see on it is H and then E0. But yeah, that's going to be it. The boards appear to be working, minus the defective fuse holder, or under tensioned fuse, I should say. All right, everyone. Well, this is a long video. Hopefully somebody made it to the end. Let me know if you did. I really appreciate your views, your comments, your support. You can follow me on social media, Facebook, Instagram, Twitter, or X at NorCal715. You can email me, norcal715videos@gmail.com. Once again, if you want to contact me, please leave me a comment in one of the videos. It is just after Cinco de Mayo. It's actually May 6th right now for a few more minutes. Oh, sorry, just turned over to May 7th. So it's just after midnight. So The year is 2025, just in case you watch this in the future, which somebody might actually watch. Okay, everyone, thank you once again for making it to the end. I really, really appreciate it. If I didn't mention it, leave me a comment on one of the videos. Trying to get caught up on stuff, just time, you know. If they made 36-hour days, life would be so much easier. Everyone, have a great day. Once again, thanks for watching. Bye-bye. Okay, so a wee bit of bonus material. I went ahead and I popped the cover off the relay. There's the spring. A lot of green corrosion on the inside of this, but look at those contacts right there. So that is what, those are the contacts that close to make the circuit, basically. And look at how nasty those things are. They are toast. That's why the inside of this relay case is absolutely black. Now, I don't think I can show you the other side because they're way down in here and it's really dark. And of course, the whiteness of the coil is moving the exposure down. I don't think I can even pump it up any farther, but I will try. Nope, it does not give me the option to go up in exposure at all. But hopefully, maybe you can see that. Yeah, you can kind of see how nasty those contacts are. They've been used up. Like I said, I'm going to recommend to the customer that he does replace this relay. Taking a look at the other one with the cover on. Those are what they should look like. Nice, bright, shiny contacts. And I doubt you'll see this side. Oh yeah, you can still see down there. Those are nice, bright, shiny contacts. That's the way it should look. And then here is the case. Remember, we looked at that with the relay assembled and how dirty that is. I wonder if I can wipe. I could definitely wipe some of it out, but look how nasty it is. Yeah, look at that. Yeah, okay, little extra bonus material. So like I said, I'm going to recommend to the customer that he does go ahead and replace at least this one relay for a cost of about 30 bucks plus shipping. But there are the part numbers if anyone is interested. All right, there you go. Everyone, have a great day. Once again, thanks for watching. Bye-bye.